let's kind of recap what you guys are seeing as the issue. I know we've had some calibration issues. When I talked with Jesse yesterday, he was describing that the output that you were reading from the valve package was not tracking linearly. In other words, he was suggesting that at 4 milliamps, you're reading 4 milliamps. At 12 milliamps, you're reading 12 milliamps. At 20 milliamps, you're reading 20. But at the 25% and 75%, 8 and 16 milliamps, your output is off. So is that what we're seeing, or are we seeing something completely different?
We personally, before yesterday, we had never been able to measure it, or before 2 days ago, but luckily the GDS guys had something to measure it with. But as far as what's going on with, for instance, I don't even know if this application is for this, and we're starting to realize maybe it's not. But this is an air over electric actuator. And what we're doing is sometimes it'll track and sometimes it'll be completely off. But we're trying to get it to track so we could track the pressure from 0 to 100 on the valve, and we could show the position of where the ball's at. Actually, track 0 to 100 on the ball position, so our customers could throttle this valve where they want it. And essentially, this positioner just needs to read that. But you know, trying to set the valve to the ball, we're having absolute hell. We had 2 or 3 that work, and then after that, nothing's consistent. We've used different boxes as far as all the same V200 positioners, but we've tried, you know, 4 or 5 different ones and coming up with different results on every one. So we're just trying to isolate what the problem is, and maybe if there's a way to tune these things that we're not aware of. I know you dealt with Jesse yesterday, trying to figure out, and I believe you guys came to the conclusion it wasn't the VAC, or possibly there was something else, because I'm running out of options as far as trying to figure out what could actually be the source of the cause.
Yeah, so when we're talking about unlinearity on the feedback, that normally results because of the calibration of the V200. So when Jesse was showing it to me, the V200, once they taken off the feedback unit, it looked to track okay. Now, we didn't get into how well it was calibrated, but what I was more concerned about was, could he get 4 milliamps, and was it rotating on the cam correctly, and were you getting, you know, 100% at 20 milliamps? And to me, it looked like it was. We had no more travel at 20 milliamps, so that told me, I assume the ball was open or closed at that point, and also inversely at 4 milliamps. Now, what we will, and we'll get into this as we go through some calibration tips. The more finely tuned the positioner is, the better your feedback is going to be, because the feedback is just reading what the positioner is. So let's take, for example, a butterfly valve. Butterfly valve is unique because a lot of times you have butterfly valves that take some force to get off the seat and to start moving, right, from closed to open. So the positioner might not move until about 5 or 5.5 milliamps. Well, at that point, we're already a little bit off on our linearity scale of what it would look like if we're tracking output versus output or control signal to output of the valve. Does that make sense? Are you guys with me? I'm sorry, say that again?
Yeah, no, it's making sense. Pretty much we're starting off in the hole, what it sounds like.
Yeah, so we're just going to go through the V200EX, and then we're going to talk about the Soldo switch a little bit, and maybe we can come up with something what's going on. Maybe there'll be something that's an aha moment with everybody. So I'm going to start off real basic, okay? I'm going to start off with just what the V200EX, what it does. So clearly this is a positioner that's going to mount onto a pneumatic actuator. Yesterday, Jesse had it on top of the Easy Torque vane actuator. It's going to engage at the top with this spindle here. We need to make sure that the spindle is all the way in. It clips in. This should engage on top. There's four mounting holes for mounting to the bracket. You can either use the metrics or you can use the standard threads on the outside, just depending on which one you want to use and what hardware you have available.
Hey, Randy.
Yep.
Give me just 1 second. It's not transferring to the big screen. Give me just 1 second.
I've always wanted to be on the big screen.
Yeah.
Should be showing. Yeah.
I agree, guys. It should be showing that, but
Another yeah, that's weird.
good call, Dean. Fortunately, that's not. And that is so weird. We have now. We only have audio, but we don't have. Oh, wow. There we go.
Good job.
Don't worry, I don't know what I did to get to this point.
Gotta change projection mode. Yeah, go ahead.
I did that. This is the only
one. That one?
When we do that, it's on here. But we're still not getting to the actual meeting again. Let's see if we can do it now. Okay, we're doing big things over here. I apologize.
We're good now.
We're good. You were
you made it. You're on the big
away.
Hi, everyone. I'm so happy to be here. All right. So we talked about the back and how we mount it. You guys seem to, at least from Jesse's point of view, that looked all right. Everything looked good there. I'm just going to talk about what I'm sorry. You got to look and see these holes here. These are your ports, right? You have your supply, which is bringing the pressure in. What is the standard pressure out at the rig sites or wherever these are going?
100, 110.
110. Okay, great. So supply is here. Then you have C plus and C minus. These are output ports to the actuator. C plus is our driving port. And what I mean by that is on an increasing signal, air is always going to be exhausted out of C plus. Okay. And then on the inverse on that, the C minus, on a decreasing control signal, air is going to be coming out the C minus. Okay. This port here is our I2P port or instrument air port. So if we're using an external 3 to 15 I2P, that's where we would pipe this into. If this is a point that I want to make sure we're clear on too, it needs to be tight. If you're having some issues reaching your 20 milliamp or 100% full open, make sure that this is tight. Sometimes they do come loose in shipping or they're not tightened when they get there. That's just a point to make sure that that it is tight.
Okay, that's a plug, right?
What's that?
Is that a plug?
Yeah, it's a stainless steel plug. These are 1/4 inch NBT threads. So I mean, just simple Allen head in here and just make sure it's tight.
Okay. We're just making sure that didn't need to be another bleed off or something because we do have those blocked currently.
Well, when we used the other valves, we had air going into those too, but those were the other variable valves.
Yeah.
Now that we're using these valves, we're not using them.
If you're using an I2P that's connected to this positioner in any fashion, such as this one right here, there needs to be nothing coming into this port. Because what's happening is this is a V200EX, so this is our I2P. So what's happening with the air, follow me here, supply comes in, 98% of the air goes to the spool valve and is waiting to move the actuator, but a small 2% is routed around to the I2P. The I2P is now regulating that air based on the control signal. So for example, if you have 4 milliamps on this positioner, a small 3 PSI signal is now coming to the diaphragm of the positioner, okay? And this diaphragm is rated 3 to 15, so it's accepting that 15 would be 100%, and it's gonna push down, okay? So what happens if this is open and we have something coming in, there's a chance that this is not going to output as it should.
Okay.
So.
I got a question for you. You
yes.
said that's 3 to 15 on that. In the event that the valve where it's going to make it turn is set 0 to 15, would that cause an issue for as far as trying to get accuracy down?
Say that one more time.
Okay, what you were just talking about was that 3 to 15. That was the air pressure, right? That pushes it in to move it. Is that what you were saying?
That pushes down on this diaphragm. It's the output of the Idp. So
okay.
if we have 120 psi coming in here into the supply of the positioner, it's going out close to 120 psi. Okay. The small 2% that's regulated back to the IDP is then regulating that air 120 down to a 3 to 15 signal based on the control signal coming in, such as a 4 or 20 milliamps.
Okay, that's electronic. Okay.
Okay. All right. So, and then the next thing are these black squares. These are gauge ports. These are 1/8 inch MBT gauge ports. We highly recommend you guys using gauges. If you don't have gauges, I would get them. One, it's going to help you with troubleshooting. Two, it's going to help you with calibration, and we're going to get into that when I ask Scott to show you how to calibrate a unit. So what we should be reading on the supply, the supply coming in, we should be reading close to 110 psi. The C plus and C minus, how we use this to calibrate is when we're at 0, no air should be coming out of C plus, okay? And then when we're at 100% or 20 milliamps, all the air should be coming out of C plus and none out of C minus. And that's that's a good way to calibrate the positioner. And then anywhere between our 0 and 100%, these gauges should be balanced. They should be reading the same amount.
Doesn't matter what that amount is.
And then the last gauge is.
Does it matter what it is as long as it's reading the same?
One more time.
On those 3 gauges, you said they need a match. Does it matter what they're reading, just as long as they're the same?
Yeah, that's correct. As long as they're close to the same, and it really that part doesn't matter as much as the 0 and 100% mark.
Okay.
That's when we want to make sure that there's no air going out of C plus at 0%, and then none coming out of C minus at 100%. And that'll all make a lot of sense here in a second when we take a look at it, when we do it live. The last port here is our Idp port, and that's measuring what the output is from this Idp. So for example, at 4 milliamps, this gauge should be reading 3 psi. 20 milliamps, this thing should be reading 15 psi. Okay. Internally, Internally, there's not a lot. We have a spool valve, a range spring, and a cam. Now on the cam, we always want the cam to rotate. I don't know how well you guys can see that, but we always want it to rotate away from there's a little, let's see.
Hey, Randy, real quick, Jesse had a quick question. What was that, Jesse?
So I want to know how we can tell where it's, you know how they use that wire to tell where he's asking? Yeah, the milliamps. What kind of tool do we need to?
I ordered that same one.
Oh, you did?
I've got a multimeter. I got it.
Okay, well,
Yeah.
make one with the game plan, 'cause you can't really get into
Is there a special tool that they use though?
Oh, yeah.
Yeah,
Is there
there's several. There's several on the market. For VAC, we use something called a Mr. Signal, and it's just something really simple. It has a 24-volt source inside of it with the 4 to 20 milliamp output. So you can't just have 4 to 20 milliamp. You got to have some power behind it. Druck makes one. I think Fluke makes some, but some you might have to have a power source with it. So
Yeah,
let me know what you guys are using, but.
We weren't using anything, but we just ordered a Fluke 771 because that's what EDS was using the other day, one of the ones that clamps onto it. So that should be here in the next few days. Yeah, we've never used any of that previous to this. We've never dealt with any of that. So.
Okay.
How is it possible that we got all those valves calibrated and out there working without that?
That is an excellent question.
Just pure impressiveness. I get it.
It's just pure Odessa genius, if you ask me.
That's exciting.
I don't know how you could have done it unless somebody out in the shop had a control signal or something that you were unaware of.
No, legitimately, we just plug it into the box, and then the boys will sit there and calibrate from there.
Yeah, so I mean, Jesse had a box outside that looked like it was outputting, 420 milliamps and tracking it.
Well, yesterday we had a gentleman by that actually had that reader. He doesn't really work for us. He was here helping us. So typically we don't have that until we bought one yesterday.
No, he was talking about the big gray box, our actual position box. Oh yeah, no, that'd be handy. But
sorry.
Yeah,
but,
the other thing is, are you buying these valve packages complete from somebody?
No, we're getting the actuators, and then as far as the VAC box and this Lotto box, we bought a few of these from Van Zandt that were complete. Well, we ended up not liking their valves, so we had our own double piston actuator we were using at one time, or we have been using with our true 8-inch bore, and our customers preferred that. So we were able to get a few done, and they worked. And then out of nowhere, we're having just a ton of issues where, like Jesse was showing yesterday, 0 to 100, and you can get 50. Anything that falls in the middle of that, it just will not work. It won't stay consistent. And then you tweak, you modify everything, you change the spin, you do this, you do that, and it's the same thing. And you throw everything so far off, it just won't get back to being on track. And that's what we were discussing. If it's maybe, is it just the inconsistency of the air? But I still have to have product for customers. So if that's the issue and this is just a poor design, that sucks, but I have to show my customer something.
Yeah. So when you're saying output, right? You're saying the output is off.
Correct.
Right. Like when we try to position our valve, it won't allow us to position. So say you try to go to 75%, and then you dial that in, cool, it's at 75. Then you go back to 25. Well, no, 25 won't stop at 25. It'll go down to like 15 or 10%, and it won't go back. So you're constantly sitting here adjusting. These boys literally do it for like 8 hours at a time, and just having absolute hell with it.
Yeah. So a lot of times in an analog situation like this, like I mentioned, the positioner's got to be calibrated perfectly linear to get a perfectly linear response from your feedback. It is not uncommon that you get off a little bit at 25 and 75. Now, when I say that, it shouldn't be 20%. It might be, less. It should be less than 2 or 3%.
We could live with 3%. We've had a few of them to that point, but with these last 3 valves, it's just been not even close.
Yeah.
I can get 0, 25, 50, and 75, but 100 will be at 80.
So to me, that points out either the calibration of the positioner is off and it's just not linear. What I mean by linear is at 4 milliamps or 0, but at 4.1, 4.2, there should be movement. And then the inverse is that true at 20 milliamps. At 20 milliamps, coming down off that 100% mark, there should be movement at 19.8, 19.7. And that's where gauges really come into play.
This might sound really ignorant, and I apologize, but when you're talking about sending these milliamps, 5 or 4 or 20 or whatever, is that the same thing as the equivalent to like air pressure? You're just sending more of current to it?
Yeah, so what I'm saying that is this positioner, you can't see it, sorry. It works on a 4 to 20 milliamp signal. In other words, we have to source it with a 4 and 20 milliamp signal for it to move the ball valve. So I don't want to get wrapped up in pressure because pressure is pretty much constant. It's just balanced based on the control signal you're sending it. So for example, if we send it 12 milliamps, what's going to happen is air is going to exhaust. Well, I don't know if you can see this, but what's going to happen if we send it 12 milliamps, it's going to convert that to 9 PSI and push down. That diaphragm is going to be pushed down, and that spool is going to be pushed down. So we have a force going down, okay? And what happens is that air goes in the actuator. It'll start moving, and because the positioner is connected, this will start moving. And it's going to rotate on the cam here, and it's going to start pushing up. So we have a down force and an up force. And when those forces equal out, we're at set point. And when we get to set point, both of these gauges will balance out because there's no air pressure going to either side because we are set at the set point, if that makes any sense or not.
Yes.
Okay. I don't know who asked that question, but that actually is a pretty good question.
It'll be a lot more apparent when we actually show it.
Exactly. So cam setup, we just want to make sure this doesn't rotate over. There's that nipple inside here, that tit. We don't want this wheel rotating up and over. We want it to be in that 90-degree quadrant, which is over here.
What causes it to jump that nipple?
Because what happens is when you mount this on the actuator, you might not notice, you might not loosen the cam up. So what I highly recommend is you set it like so with the cam nut loose. Put it on the actuator, make sure it's in the set point, and then tighten it up, hand tight, and come back with a screwdriver and tighten that set screw down. But a lot of times what we see customers do is they'll get it. Let me show you. They'll get the positioner and they'll go out to mount it, and they won't worry about where the cam is, and they'll set it like this, and that's their 0 point. I don't know if you can see that or not, but that cam is rotated way over. So what's going to happen is we'll give it some input and maybe nothing happens, or the cam's on backwards, and what happens is it'll increase, and then it'll pop over and fly. So what we need to do is when we go to set this positioner up is mount it with it loosened, tube it up, tighten it down, and the very first thing, and I got Jesse to do this, is to push down on this balance arm. And when we push down on this balance arm, we're mimicking a control signal. So the spool valve is going to push air out of C+, and the actuator should start moving, and the cam should start moving. And we could watch and make sure that the cam is rotating in the correct quadrant. It's not rotating up and over this nipple. It's going in the direct direction. If we push down on it and nothing happens, that's typically a tubing issue. We need to switch the tubes to C+ and C-. If we push down and it rotates up and over the cam nut, or sorry, over the nit, over this tit here, we know that the cam's on backwards or the cam needs to be adjusted. Okay, so again, just by pushing down on the balance arm, that really helps us determine if this is pneumatically set up correctly. Is everybody understood on that?
Yes.
Okay. Is there a question?
Yeah, we've done that. I've moved it to the side, but I make sure that it don't ever jump that nipple. You know, yeah. So it can be turned to the side, but it'll go either this way or it'll stop. You know, it won't ever cross that.
Okay,
and we've made it work like that.
Okay, and then one other thing is too is yesterday or night before, whatever night that was, the valve guy said that the ball was rotating the wrong way. So whoever rebuilt it set it up wrong. That's mind blowing to me, whatever. But what I'm concerned is maybe if he was wrong on that, because I mean, we've had a situation, we've had two valves that he said that the ball valve was rotating the wrong way, but I mean, it still functions. It opens and closes. And if it's not working one way, you flip the cam over and make it work the other way. But I wonder if that's not part of the issues we're having on this particular one. But I mean, we had two different ball styles, and on both these valves, we still have the same issue. So I don't know. I'm just trying to put everything out there. So I don't want to, if I have a half-assed thought, I want you to know just so you have an idea. Maybe it's something we're thinking about different.
Yeah, Scott, you want to speak to that? I know you have a little bit more hands-on experience than I do with ball valves and whatnot.
Well, when we're talking about what kind of output we're getting, are we actually reading the transmitter, or are we just looking at the scale?
We're looking at our touch screen. like our PLC.
Okay, so that's actually reading the position back, but we're not reading we're not trying to. It's not a flow meter we're reading, but we're actually reading the output back out of the limit switch or the feedback that's mounted to the positioner, correct?
And we're trying to program that so it controls our ball valve. That's his whole setup. It's a PLC that's got the VAC box and the Solato on top of it, sitting on top of our valve.
Okay.
And then we're trying to get that to go to 0 to 100 and be able to go whatever we need.
Okay. Now, as far as what they're saying about the ball turning the wrong way, it's possible that when the actuator gets mounted, the only thing I can figure is that when the actuator gets mounted to the ball valve, that it's out of phase, because most ball valves, if you take the travel stops off, they'll spin 360 degrees. So it may be that it's just the actuator and the valve are put together out of phase, essentially, so that now it's going clockwise to open versus clockwise to close. But that won't really affect it would definitely affect the flow going through the valve, but that wouldn't have any effect on what we're talking about as far as 4 to 20 milliamp input coming in and 4 to 20 milliamp coming out of the positioner. That really would only affect actual flow. But as far as what we see, go ahead.
Will that not affect it because that's just the control panel telling the valve what to do? It doesn't really give a shit what position that valve's in. But it doesn't know that it's crooked.
Right, it doesn't. It doesn't, because all this device knows. And this, when we talk about open and closed, the positioner doesn't know open and closed. It just knows one position and the other, and it's up to you to tube it, or it's up to whoever mounts it up and how they want it to be configured. So we see a clockwise and counterclockwise rotation, whether clockwise is closed or open. This doesn't know. It doesn't know. It just knows that the 0 position is wherever you set it. So all it knows is 0 and span, and that it's going from 0 to span or span to 0 and anything in between. Now, whether that's open or closed on the valve side, we don't know. This thing can't determine that. Our positioner can't determine that. Neither can the feedback, really. But you just have to make an assumption.
Our valve guy thought that was part of the issue, and so he had to break down the valve again, switch the ball around. He was thinking that was the reason why why it wasn't functioning, doing what we're thinking. So I'm just trying to think of whatever scenarios are.
So when you see a 4 milliamp, or let's say 0% out input into the positioner, you want to see 0% coming back from it. Well, then you increase that to 50%. Well, as long as you see 50% input coming in, and then the soldo's giving you 50% back, everything's good. You get to 75% signal on the positioner, and you get 75% back from the soldo, from the transmitter, at least it's tracking the correct direction. Now, if the ball's in backwards, now if you started it closed, this thing thinks 4 milliamps is closed, and you've rotated to 75%. Well, you think 75% is 75% open. But if the ball's in 90 degrees off, now you're 25% open. You're inverse. So that would be something you'd see on a flow meter, actually seeing flow. But as far as output on the positioner, you can still make those track, but something strange may happen in your actual flow through the system. So as for what we're seeing, unfortunately, a ball being put in 90 degrees off, the issue you're seeing, that's not going to change that. That's not going to affect that any.
We're not going to see any flow when we're calibrating it here at the shop.
Yeah. Before it gets put in line, you should see that. So I'm making some assumptions here that 4 milliamps is generally going to be the closed position. Is that correct?
But my thing is, even if we're calibrating these here, hypothetically, if this was actually properly working the way we wanted to, building this thing with no pressure versus going out to the rig and having a bunch of flow, wouldn't that change everything up? I mean, as far as you're going to have to apply more pressure to close it when you're not flow going against it?
You got resistance?
Yeah.
No. That's when you calibrate from 4 to 20 milliamps, as long as the actuator sized properly, then that shouldn't change much of anything. Because that's kind of that's why we talk about the force balance. That helps with that. And as long as your actuator's strong enough and sized properly, that's when you look at the pressures and flows and pipelines, that's when you have to, that really only comes into play when you're actually sizing the actuator. If the actuator's undersized, yeah, it could be a problem and it's going to cause issues, but that's not really any fault of the positioners because it can only use the muscle it's given, and that's the actuator itself. So once you get it in the line, as long as it's scaled 4 to 20 and 0 to 100%, then it's, as long as everything's sized properly, it doesn't change. So it'll affect, 50% is 50%. It doesn't matter whether you have 0 line pressure in the line or you have 100% of whatever your normal pressure is. As long as the actuator sized properly, 50% is going to be 50%, 25 is going to be 25, and 75, 75.
Does that make sense? We good?
Sure. Thank you. Yeah, that makes sense.
Yeah.
And that kind of goes back to old school stuff where a bunch of the old stuff was 3 to 15 input. Actually, that 3 to 15 signal Randy's talking about actually went straight into the actuator. Well, now we can get away from that. We can put 60 pounds of air on that same actuator because we're using the positioner to position it versus just putting a load on top of a dome on an actuator. So now we can increase the strength of the actuator by increasing air pressure because we're using whatever supply we have available versus just the 3 to 15.
Yeah, I noticed the one you have there on your desk has those gauges on the outside. Ours does not.
Okay.
Yeah, does that?
Yeah, that's one thing Randy said a while ago, and when we go over it in a minute, we'll actually show it. Those will help a lot in calibration and troubleshooting. Those are really what having the gauges would definitely help you in this fight you're seeing with the calibration moving around in the 4 to 20, in the 0, 25, 75.
Put the gauges on it to calibrate it and get it good to go, and then take the gauges off whenever we send it out into the field.
Yes,
or do we?
That happens a lot. I've done that a lot in my past. That gauges, they're pieces of thin metal and glass, and they get broken easily. So if you just put them on to calibrate them, take them off, put the plugs back in, and you're good to go. But the gauges will definitely help you with calibration.
Okay, good.
Yeah, as far as the functionality of the positioner, they don't really do anything. They don't help it work any better. They help you determine if there's an actuator problem or determine what's happening with the positioner. But as far as it actually working better, it doesn't. It doesn't do anything. Now, if you have a gauge on here and somebody busts the gauge off, and that's now an air leak, well, it's going to be detrimental to the functionality of it.
Is there anybody that makes these that are, or do you guys make these that is not made out of hard plastic? Because we've got rigs that really break those rigging up. And we've tried from putting big metal cages around to protect them to anything. Does it have to be a hard plastic, or can it be made out of like a steel with a polyurethane over the top of it, so it wouldn't be spark resistant or anything to that effect? Or is that something you guys have ever considered?
Oh, for the gauges?
No, for the actual box, the plastic box. Because you see how you got your gauges going in there?
Mm-hmm.
When
Plastic box. What plastic box are you talking about?
That gray and blue, the whole setup itself.
Yes.
Yeah, that whole
right
thing.
there.
This is cast aluminum.
Okay, well, we're breaking fittings off, and it's cracking the cast aluminum. Where the NPT comes in, we have rigs that will go to rig it up and literally break those off.
These roughnecks will break a sledgehammer real quick.
Yeah, that's. I'm not going to say it's not happened before, but these are pretty. In fact, we've actually beefed up these parts here, where it takes quite a bit to break it.
Yeah, we broke several of these end pieces off. I guess we could just replace the end piece.
Not us in-house. Our customers are careless.
I got that.
Yeah,
I'd also like to really see those. So if you want to send those back to us, I really would like to take a look.
Okay. Yeah, I promise.
Yeah, it's not a problem
we had one ready, and I shit you not, as they go to nipple up, which the first thing they do on the rig, they broke it lifting it. and they snapped it off.
Yeah.
And,
so I mean, that's. I mean, this is an instrument, so I mean, you can't treat it like a piece of pig iron. You can't like put a loop here to pick up a 700-pound valve package. It's gonna break.
It's just not made for the oil field, is what you're saying.
No, I mean,
you got to grade with a curve with some of these guys that they're on the craze, man.
we call them Bubbas and everything else because they're all over the place, and they'll take a sledgehammer when there should be a screwdriver used. Yeah. We have them. I mean, they're all over the place. It's just it is what it is. I mean, if they're going to have a control valve package, they're going to have positioners, and if they're going to hook up mine or anybody else's, it's going to be the same situation.
Yeah, for some reason, that's why I thought it was plastic. I put it in my hand. I obviously realized it's not, but that's why I thought it was plastic, because we've broken several. Or not several.
Yeah, I mean, so imagine how much torque they're putting on this to break that. I mean, that's quite a bit of torque.
You should see what these rigs have to do to rig our valves up and down. It's pretty sketchy.
Yeah, I know. I've been there. So really fast, this is the spool valve. And then we're going to get into calibration. I think I've talked long enough about all the little components, but this is unique to valve accessories because our guy who's been engineering these for a long time has gotten this down to a science. And what the science is, it delivers a lot of air with bleeding very little. This is a stainless steel piece. Inside here is also a stainless steel piece. This is a cast aluminum body, but the spool piece is actually coated in gold. And why that's important is the gold acts as a soft metal on stainless. So it basically acts like a natural lubricant. So what that means is we don't need to add oil or WD-40 to this. The biggest thing is just contaminants in the air. If there are contaminants, after a while, this just needs to be taken out and cleaned out. Either just wiping it down with a towel or just blowing it out with air. It only can go in one way, so you can't screw that up. I've seen people try to do it backwards, and they failed. So Scott is going to go ahead and just walk us through how to calibrate a unit and how to set it up. I know I've talked a lot about certain things, so hopefully all those little things kind of come together here.
We definitely appreciate you taking the time.
No problem. And again, I apologize. You guys have had so many issues.
On the learning curve, can we order them? No.
So one thing Randy had talked about, I think you guys are kind of past this point. This is something y'all got pretty well. But like I said, you snap the spindle in the back. One thing is we always talk about when we mount them up is that we always want this cam to be loose. And the reason we want the cam nut loose is so that, like you talked about, you can set this up in a bunch of different orientations and configurations. But if we break this cam nut loose, so we loosen the set screw first, loosen the cam nut, that way when we mount this on, we'll mount that up, now we can mount it in any direction and that cam is rotating with the positioner. That way when we lock it down, now it's going to be locked in the correct quadrant, in the correct configuration that we're looking for. So I'm going to throw some screws in quick.
Can you guys see that all right?
Yes.
Hey, real quick, Randy, do you have these V200 positioners? Do you have anywhere local in Odessa that actually carries them in stock? So far, everybody says they got to order them from Houston.
No, I don't. There's nobody there. You could put a bug in Van Zant's ear that you're going to buy some, and they can get them out of Houston, or
you tried with them in 2 days to say that it'll take 2 days. Okay, well, I'll keep searching around and see if I can find something. I mean, you guys don't direct.
What's that?
You guys direct ship?
Yeah, I mean, if they place an order, Van Zant or Eads or whoever you go through, we'll ship it out direct to you guys, no problem.
Yeah, can we go premium to you guys, or is that a no-no?
Well, no, because you guys are you are the end user pretty much. So I prefer there be a buffer between us and somebody that could actually help you. And somebody from Van Zant should be able to come out and help you as well. They're pretty savvy. There's another company called Bertram. I don't know if you know Mike Candy out there in Odessa.
Mike Candy?
Yeah, Mike Candy at Bertram. They're pretty good also. I don't know. I don't know the Van Zant guys in Odessa very well. But I do know the guys here in Houston pretty well, and I mean they're a good bunch too.
As far as that Bertram, do you happen to have a contact for them? I'm trying to Google them right now.
Yeah, hold on. Give me a second.
Sorry, I didn't mean to slow down progress.
They're on 2nd Street in Odessa, and I can give you their number.
Yeah, that'd be great because apparently I'm either spelling their name wrong.
It's Bertrem.
What was that phone number?
Phone number is 432.
Hold on.
Yep.
Okay, we're good.
Yeah, go ahead.
432 332 1800. And I don't know if I know they don't have them in stock, but again, they'd be good guys to help you out with. So.
Yeah. Okay, sorry about that. I do appreciate it. Thank you.
That's all right. So what it is, went ahead and bolted this up. I tightened this cam down. I left a little gap inside the little, it's going to be kind of hard to see, but inside of here, you're going to leave a little gap between that little cam stop or that little tip and the roller bearing, because what that allows you to have a little bit of adjustment in your zero. So I went ahead and locked the cam down. Everything's bolted down. Like Randy said earlier, supply is the center port, and we got a maximum of 145. So the 110 you guys are seeing is going to be fine. The C plus and C minus, like Randy said, at 4 milliamps, which is generally the zero position, we're going to see all the pressure coming out of C minus and nothing out of C plus. So the reason we said the C plus is the driving port, as we increase signal, we're going to start seeing output of C plus increase. So what we want to do is we're going to set this up as 4 milliamps closed clockwise direction. So what I'm going to do is I'm going to push my I'm going to connect my C minus to the closing port, C plus to the open port, and I'm going to hook up my generator. I don't know if you guys are going to be able to see this well. We'll go ahead and clip on here. We have our Mr.
Well,
Six.
what are the other end of those hoses connected to?
We need those good ones.
The other end of these hoses,
Yes.
they're actually connected to the actuator on the backside here. So I've just got a rack and pinion actuator, and they're just connected to the open and close ports on that rack and pinion actuator. So one side, and I've got one side, my supply is going to the compressor, but that's, they're just connected to the actuator. So one side of the positioner, one side of the actuator.
Our actuators have 4 different holes. How do we know which holes to plug those hoses in?
Yeah. So they have the Easy Torque with that Nomore, I think it's like Nomore spool valve. And that would have, and quite honestly, I don't know who asked that question, but you're going to have to look at the Easy Torque manual on that. So the 2 outputs of the positioner should go into that Nomore switch or whatever it's called. And then from there, it goes on the other side, it goes to the actuator. I've only seen it a few times, so that's just something you're going to have to reference through Easy Torque.
Yeah, through Easy Torque, that's going to, we don't have one. I have an Easy Torque actuator, but I don't have that spool valve. I don't have their trip valve. All I have is basically the Easy Torque I have is just like this actuator. It just has 2 ports. So that's something to look at there. But once you get that literature or the correct information from them, the C plus is going to go to your driving open, and C minus will go to the driving port, the driving closed port on the Easy Torque. Now, with like Randy said, I can't really tell you what those are because I don't have it in front of me. Once I get one in my hands, we're supposed to be getting one pretty soon. I'll be able to help you out with that, but currently I don't have one.
And feel free to call Easy Torque. I'll be glad to give you their number as well. They're very good at customer service. We have a pretty good relationship with them.
Yes.
So feel free to give them a buzz.
Okay, perfect.
So we've got the unit set up. I'm gonna go ahead and put some air on it. One thing you'll notice, since you guys are mainly doing the EXs, a lot of people, I don't know if you guys can hear that constant hissing, but the V200, like Randy said, is a pilot valve type positioner. It's always going to bleed air, but we've gotten it down to where it'll bleed less than 0.2 SCFM of air, because what we're doing is, like Randy said, with that gold stem inside that pilot does help lubricate, but with that air constantly flushing through it, it acts like a air bearing. So now that pilot valve is real sensitive to small signal changes, so it can move. You know, that makes the positioner really responsive. Another bleed you'll hear is actually from the bottom side of the IDP. Same thing. This is basically, the IDP is essentially an electronic regulator, so it's bleeding off the excess pressure for the set point you've given. We'll go through calibration real quick. Like Randy said, what we'll see, I'm going to try to get it to where you guys can see the gauges. It's going to be, so if you'll notice right now on the gauges, I'm at, let's turn the actual output on. So on the Mr. Signal right now, I have 4 milliamps. It's going to be hard to show you both, but I've got 4 milliamps on the Mr. Signal here. I'm hard to see. But at 4 milliamps, that's our closed position with our cam set properly. Well, one thing we'll look at real quick, like Randy said, the test to make sure that our cam is in the right quadrant or we're set properly, what we can do is reach above the pilot valve and press down and see that the cam turns the correct direction. So we're turning counterclockwise when I press down, so when I release it, it goes clockwise. So we know pneumatically we're hooked up correctly.
So going the opposite direction, what's the problem and how do we fix it?
So if it rotates the wrong way, that means there's a chance that on a double acting or something, you're starting in the opposite. Let's see. This is set up direct. If you want to get, I'm sorry?
So does that just mean the hoses are backwards?
It could mean that the hoses are backwards, but generally if it works and it jumps that cam or works the opposite direction, is because where you started in the position you started in originally with the valve and actuator package is the wrong, it's already in the 100% direction.
Hey, Scott, just flip the tube so they can see what we're talking about when that happens. So, for example, if you tubed it up backwards, this is what's going to happen. When you turn on the air to the positioner, it's going to stroke the valve full open.
Yep, so C is up soon. Because at 4 milliamps, we have 100% output on C minus. So now we've changed it from closed to open. So as soon as we put air on it, it's going to go fully open, even though we're at the 4 milliamp position. So now, as I increase signal, I've got 20 milliamps, and it's dropping back, but it's because it's bleeding off. But it won't modulate anywhere in between. It's only going to go full open, full closed.
Okay, that makes sense.
Sorry?
It makes sense.
That makes sense.
So the point of pushing down the balance arm at this key point, if we push down the balance arm right now, nothing happens.
Yeah, nothing's happening.
So that should tell us immediately right then and there that our tubing is backwards.
Yeah, if you push down on that balance arm and nothing moves, that's pretty much, like Randy said, a dead giveaway that the tubing is backwards. You can have the cam on the wrong side and make it rotate the wrong way. There's some things that happen there. You won't get controlled. You can get 0 and 100% maybe. But the reason why it's actually going from 0 to 100% now is because all we're really doing is flipping these outputs. So even though it's starting wrong, it'll drive to the other position. But if you'll notice, as I change signal, nothing in between is happening. It's not changing until I get to 20 milliamps. Then it strokes all the way. So that's a dead giveaway that, like I said, press down on this arm and nothing happens. So if you press down on that arm right there and nothing happens, it's pretty much a dead giveaway that we've got the tubing backwards.
I know those gauges and that little chuck valve, whatever you got there, do you guys sell that, all those little tools?
Yeah, the Mr. Signal, the little calibration tool.
I'll have a calibration one, but as far as that particular one.
No, the reason why I say that is I was different. How did you hook that one up? I see the 2 wires going to that thing. Did you just connect it to it?
Yes, this unit is just connected directly to it because this unit generates a 4-to-20 signal with 24-volt loop power built in. So it's both. So with loop power system, you've got power and signal on the same circuit. So this Mr. Signal generates both. So you're able to just hook up the 2 wires to the positive and negative, and it'll read and generate. Well, it'll generate. The Mr. Signal has the added benefit of I can hook up 2 more wires, and I can also read once we put the limit switch and positioner assembly, feedback assembly on it, we'll be able to read that as well through the same device. So you'll be able to calibrate both with the Mr. Signal. So that was one thing. Were you guys able to calibrate the feedback, or were you just calibrating only the positioner?
We haven't had a
So were you adjusting both or just the positioner?
Oh, we never had that little box, so we've just been messing with the with both of them.
We would eyeball the ball we would set the ball just by eyeballing it, and then we would adjust the cams, eyeball it too, and we just eyeball it until it lined up.
Okay.
It'll take us hours and hours and days sometimes.
Okay, well so once you guys get the right tool, like when you get a calibrator and you get something that you can read that 4-to-20 with the transmitter, that's going to help. It's going to go a long ways to taking that guesswork out because you can actually see what the output is. And another thing is getting a set of gauges. Like you said, if you just pull the plugs out, put the gauges on to calibrate it, take the gauges out, put the plugs back in and send it, that's going to go a long ways to helping you where you're not chasing your tail, fighting this constantly.
Those black plugs that are on there, do you unscrew them or do you pop them out?
They're MPT 1/4 inch.
Yeah.
And if you don't want to use the black plastic, you can just put a regular 1/8 inch MPT hex head plug back in its place.
Well, are those black ones good enough to stay in there, or should we upgrade?
They're full pressure rated. So our positioner is good for 145 psi, and those plugs are good for 145 psi.
Those ones that you got right there that you have your hand on, what do those go up to from 0 to what?
These are 0 to 160s.
And we have those.
And the reason, obviously the reason why we do 160s is because if the unit's rated for 140, you don't want to max your gauges out. You want to be somewhere closer to the middle of the range. So at 140 psi, we're pretty high on the range, but if you put 80 psi gauges and you put 100 pounds on it, obviously it's not going to read accurately.
We could just use any 0 to 160 psi gauges on those, right?
Yeah. If you're just using 110 psi, 0 to 160 pound gauges work great.
Yeah, and really when you're calibrating in the shop and you know how much your planner or your instrument area is, you don't even need one in the middle. You could just put one on C+ and C- and move on down the road. Now the other gauge on the very top is a 0 to 60 gauge or 0 to 30 gauge. I'm sorry.
Yeah, 0 to 30 here.
0 to 30, and that's just reading the output of the IDP. And the only reason why you might need that is if for some reason you're having issues with the IDP, for some reason you don't think it's tracking correctly. That's just a good way to test it. The only two that you really truly need are those two 0 to 160s that Scott had his hands on.
So that little machine and those gauges are going to help us out tremendously.
Yes.
Yes.
We've been really trying to eyeball stuff, just free balling, and the ones that we got right, we just got lucky. Like it was a hit, and it was like a winning jackpot. And
well,
the ones we're like way off. I bet you if we had we can make it.
Honestly, a lot of these positioners out of the box, for 0 to 90 degrees of rotation, as long as you get the cam set right, they're going to be really close right out of the box, 90 degrees of rotation. Now, if you start changing if the cam's not set right or it's off, you know, if you've got your travel. So when you do a valve package, the first thing I always did was, you know, make sure you manually put your ball or butterfly, whatever it is, in the 0 position. So if that's closed, closed, then make sure your actuator's in that, whatever that position is, mount them together. Then you set your travel stops on the actuator so that you're going 0 to 100%. When you get that set, then the positioner is going to be easy to calibrate. If you go in and you change the travel stops on your actuator after you've calibrated your positioner is going to be off now because you've changed where that 0 and span is. And I'll show you that in a minute on the gauges, how you can tell that. But as far as calibration, the gauges help a lot with the calibration. So that's the thing is, so you have to kind of start at the bottom, make sure everything's in place as you go up.
I see you button and it closes and opens it, right?
What now?
On that little box, when you put it to 4, it'll close it or open it, right?
Correct. So what I'm doing, so like Randy said, as you put 4 milliamps on the Idp, that's outputting 3 psi onto this diaphragm. So at that position, all the air is coming out of C minus, driving it closed. So 4 milliamps is closed. As I change that command signal to up towards 20 milliamps and go all the way to 20 milliamps, so this is taking that 20 milliamps, converting it to 15 psi on this diaphragm, and it's pushing that spool down into that spool valve like we did manually a while ago. So what that does is that flips the output on these. So now C minus has no output, it's venting, and C plus now has full output, so it's driving it open. So this, when you're using this box, 4 milliamps is closed, 20 milliamps is open in the way we have it configured.
What would be in between, halfway?
That would be 12 milliamps.
You can put it on 12 and it's going to stop right at 12.
Well, that's part of the calibration. So I'll go through the calibration now. So all we've really done is shown open and close, kind of give you an idea of how it operates and functions. I want to make sure I change this. So we'll put the air back on it and it'll drive back closed. Because like I said, I have the C plus going to the open port and C minus going to the closed port. I can push down on this lever and you'll see that it's going from 0 to 100%, in the 0 towards 100% on the 90-degree linear. Because we're rotating 90 degrees and that's a linear feedback or linear output. So first step of calibration is you start at 4 milliamps. And if you'll notice these gauges, guys, I don't know if y'all can see them well.
Yeah, we can.
So we have the supply, the C minus, and the C plus. You'll notice that the supply and the C minus match. So what that's saying is I have 80 pounds of air on it. It's putting 80 pounds of air on the C minus and 0 pounds of air on the C plus. So what that's saying is whatever that C minus is hooked up to, it's driving that direction. So it's in the closed direction. It's on the closed port. So at 4 milliamps, I've got 0 output on the C plus, 100% output on the C minus, so it's closed. The calibration for that is, if you look inside, Randy, can you show this? Hold up your position.
Yeah.
And so in the bottom port, this rubber plug that comes out, you'll see kind of 2 screw holes.
I don't know if you guys can see me. Let's see if
Yeah, we got one here in front of us also.
Okay.
Okay.
That's
that
what
port,
we use in that ball valve.
you explain it so you'll take over the screen when you do it. If it's on
Okay.
screen for you.
Yeah. So this is where the center screw is where we this is where we set our 0 or our 4 milliamps. So what we're going to do is turn it one way or the other to see where that bottom gauge starts to get air. So we'll rotate it a little bit until we start seeing that needle move. And then we come back about a quarter turn so that we make sure that there is no air coming out of C plus. So as Scott turns it.
So see, as I turn it, we've started to see output pressure on this C plus. What we'll want to do is turn it until we see output start. We start seeing output on that gauge. Then we're going to reverse directions again until we get that gauge to go to 0. And 3 to 5 seconds, or the quicker it goes to 0 means the harder it's going into closed position, that it's going closed that much faster.
Now, one thing to point out, you guys do have a pretty large actuator, and Scott's actuator there is probably about a half the size of the one that you guys are using. So there is going to be some time for that air to exhaust. So if you start seeing that needle start coming down, give it a few seconds before you continue to rotate it, because it might be going down slowly versus just really quickly. And if you adjust to 0 too much, you might be off a little bit.
And one thing,
well, times that there's been about a 60-second delay for it to catch up. Is that a valve issue or a blue box issue?
It depends on the size of the actuator. So that's a statement that I have to put in little points to. So for example, if we have a huge Scotch yoke actuator that's, I don't know, has a bore diameter of 12 inches or more, there's a lot of air inside of that actuator, right, to provide the torque. So it's going to take a little bit of while for it to bleed off. And I don't know what size actuator you have. So I will go off what I saw yesterday with Jesse. That actuator, it shouldn't take 60 seconds for it to move or to stroke. I mean, it's going to take some time, but it shouldn't take 60 seconds.
If I move to a valve, it's not that long. Sometimes it is and sometimes it's not.
Well, I mean, again, it's all about the volume of air that's inside the actuator. And depending on that, I mean, you have the spool valve, which is rated for 28 SCFM of air, that it's got to throttle that air inside those chambers. So it just depends on how much volume you have.
Okay, but when I do it on 2 different valves, they're the exact same actuator. And on one, it takes 60 seconds. And on the other one, it might take 10.
There's probably something going on as far as tubing is concerned, or I don't know who's asking that question, so I'm sorry I can't address you by your name.
It could be tubing or action. I mean, it could be in just the calibration. That even though 4 million, that's where that's one of the things where if you're reading an output, once we get the feedback put back on this unit, once this goes to 0, you may still be seeing the valve move, because what this is reading is what the pilot valves actually do. You still may be exhausting air, and the actuator may still be moving to that position. Because like Randy said, if it's a large actuator, it takes a while to exhaust all that air. But once this is on 0, you're not outputting any more air trying to make it go open. So it's going closed. It may take a while for it actually to get to close. And that all has to kind of do with how you've got this 0 set. That you can adjust that 0 a little bit and you make it close a little bit quicker.
And the other thing I want to point out is if you're using the same actuator on those 2 valves you're talking about, so yes, 2 identical valve packages, are you using that easy torque actuator for both those valves, or are you using something else?
It's the same actuator, but it's not easy torque.
We've got
okay.
That is valves.
Okay.
We have different styles. We do. The easy torque, for instance, we didn't prefer that in the past. Our customers like having our big actual valve that's got a true 8-inch bore on it. And then as far as that goes, I would have to send you a picture. Did you show them the one with the double canisters yesterday, or was it the red one? The red one?
Mm-hmm.
Okay, so that would be the true torque.
Oh.
We have a different style that we were using before, and it has been working. And then, like I said, everything just got thrown off. And we could have just show you that after the meeting as well, to show you what we got going on. And it's a double or dual canister, like a piston style actuator that we were programming.
Well, the problem that I'm seeing right here is we didn't have these gauges on there or that little box to tell us where we're at. So we've been using that screw on the side that you just screwed, and we've been that one. So we've been just turning it till we get the ball, and that's probably what it is. We're throwing it way off. And turn it back.
Doing it without gauges, you're kind of have, and that's, you can calibrate without gauges, but Big valves are hard to do because you're having to watch for movement, check for movement, listen for a sound change as to when it changes, that you can tell when it's starting to output pressure. So it's hard to be repetitive. Where if you have gauges and you have that, we have a single page sheet on the website, and Randy can send it to anybody, that is calibration to gauges for a V200. And that way, if you do it, if everybody does it off of that calibration sheet, then it's going to be the same. It's going to be repeatable. So those two that you have, that one takes 60 seconds to close, one takes 10 seconds to close, if you calibrate them with gauges to that sheet, they're going to be a lot closer to that, to each other. And but most likely that's why you're seeing that long time between one stroking and the other one stroking. It's because without having gauges to calibrate it properly, you're just having to do it by feel and kind of just by guessing, kind of taking an educated guess at it. And that's going to be hard to be repetitive with.
Speaking with Bertram a few minutes ago, he says those gauges are something he has to order from the factory. Is that something you guys get in stock as a factory? I think those gauges you can find them anywhere.
Yeah, those gauges we can get. We got those. They're 0 to 1.8, 1.6. We got those in stock. We can use those. We can get those.
Adapters for
the only thing that we're gonna need is that box to hook up. Let us know. And all this part right here is what we can do. What we've been doing. What box? It's harder. This will make it easier for us.
That might have been when I said that. What box are you talking about?
Something about his So like we've been doing this. This is longer, but we can get this part. Right. And this right here is going to make it way easier for us.
As far as the box that you're tuning it with, it looks like I was looking online. The fastest I could get one in is November 4th. And then this gentleman that I just talked to, he says they may or may not have one. They're supposed to get back to me. But yeah.
Yeah. We stock these.
Right? You stock those? Okay. Can I buy them from you, or do I have to go through someone else to buy them?
That's Randy.
Go through Bertram or Van Zandt.
I'll see if he can do it. He said
he was going to get back. It's a Mr. Signal.
Yeah, that's what I told him.
It's 300, 400.
So all this.
Part number's what, Randy? Is it 300, 400?
You know what? I don't think I have that part number. I always have to ask for it.
It's at the bottom of the cut sheet. Do you have it?
No, but I can get it. Hang on.
This right here. This is going to make it really easy. You know what I mean? And we're going to do it the right way. We're going to do that other part when we put it on.
Part number.
Got it right here. Well, I see it's the part number 300, 400. Yeah, that's correct.
300, 400?
Yeah. I'll screenshot that and I'll text it to that gentleman so he knows what I was. Well, I asked him if he had them, and he says that they'll have to look, and he doesn't know if they sell them. So I'll shoot it to him so he's got a copy of it. Okay, thanks, guys. Sorry about that. I'm just trying to make sure my guys got all the tools they need, because as of right now, it's kind of like, hey, fix this.
You said y'all
did buy the Vince was supposed to order. I don't know if you ordered it yet or not. Okay, sorry about that.
That's all right. So what we did there was all we've done so far is calibrated the 0. So what we're going to do next is we're going to go to, but we're going to, one thing you can do once you have the signal at 4 milliamps on your whatever calibrator you're using, Mr. Signal, Drup, Fluke, Amtech, whatever brand you're using, what you can do is just kind of bump that arm down and watch these gauges. As you push it down and then release it, we want to see that gauge drift down to 0 in about 3 to 5 seconds. And what that's doing is you'll notice as I push down, all the gauges move, these try to balance, and as I let it go, it drifts down to 0 in roughly 3 to 5 seconds. So now we know we've got our 0 set pretty close. We're pretty happy with it. So what I'm going to do is I'm just going to drive this I'm going to drive my signal up to 20 milliamp, which is going to be the open direction. And a while ago we were looking at 0 in this gauge. Now we're going to look at 0 in this gauge, because now we want full output on C+, because we're in the fully open position, and we want 0 output on C-. So we've already got that. It's already set, but I'll show you how to check it. Randy, you want to show where the span adjustment?
Yeah. So the span adjustment is this outer wheel, okay? So 20 milliamps, this is where we're going to make that adjustment. We're going to get inside. Can you guys see me?
Yes.
Okay. So we're going to get in with a flathead and we're going to rotate it one way or the other.
So yeah, you've got 4 vertical and 4 horizontal slots in it that you can adjust. But what we can do is kind of do the same. What we're going to do is look at the same kind of processes. We're going to adjust that span wheel until we see the pressure rise on this C- gauge. We'll see it rise, and then we're going to back it off until we get it to 0. And now we can do the bump test where we bump it and come back, and it's going to close at it's going to go to 0 at about the same speed as the other gauge did when we were at the 0 direction. So now we're
whenever you turn it with the screwdriver, the little screw in the middle, it turns too, or do we have to make sure that one don't turn?
Yeah, you do not have to hold it. Once you have the middle screw, so you just turn the outer. You don't have to hold that middle screw. It'll turn with it, but it's kind of the way it's designed is it's meant to be turned because that adjusted one end of the span, the 0, and if you trust the other, you're just adjusting the other end. Because inside here, there's a small screw, and then the larger one, you're just adjusting a very coarse screw.
Okay, appreciate that.
So if you've held that while you're turning that, basically you're fighting yourself because as you turn it, you're adjusting the 0 out of adjustment again. So you'll have to go back and adjust the 0 if that's what's happening. But we can double check again where we can push up since we've got 20 milliamps on this. It's putting 15 psi, so it's pushing that stem down. So now if we push up, we can see it move, and we can double check that. We can push up and watch this come back down to 0. So now we've got the positioner calibrated pretty good to where we're at 4 milliamps is closed, 20 milliamps is open.
And the other thing you want to check too is not just the 4 and 20, but Scott, show like when you start ramping it up or down, when you start seeing movement at either 4 milliamps or 20 milliamps.
Right.
Because this will also help with the linearity of the feedback.
So as I start scaling down, depending on how sensitive, and this is one of those where if you get it 3 to 5 psi, it's going to be a good average. If the slower this comes down, the slower these gauges go to 0. If you make it take 20 seconds to get to 0, and 20 seconds to get to 0 on the other gauge, what that means is as you increase signal, it's going to be a lot more sensitive to start moving a lot quicker. So as we start scaling down, we've got these set to where at about 18.5 we're seeing movement, but now as I'm just scaling down scale, you'll see that it's just, so anywhere I want to stop, now it's modulating in the middle. And we'll go all the way down to 4 milliamps real quick. And now we'll come up. So at 4.4 milliamps, we're seeing movement. We're actually seeing movement at 4.2. We're seeing pressure build on this gauge, but we're not seeing movement yet. But if we go up to 4.4, 4.5, we actually see this gauge start moving and we'll start seeing movement. So now if we go to 12 milliamps, which is going to be our 50% mark, and one thing Randy talked about is balancing, force balance. If you notice, the supply pretty much always, it jumps around when it sees a pressure change. But anywhere in the middle of stroke, other than 4 and 20 milliamps, these gauges should match, especially with a double acting. On a spring return, it tends to get a little funny because you're fighting a spring, but they're going to try to balance each other. The only time either one of these gauges should be at 0 is at the end of stroke, either whether it's open or closed. Any questions on anything so far on the calibration, guys?
Oh, that makes perfect sense.
So one thing, Randy, we kind of went over a little bit, but this gauge, like I said, like Randy talked about earlier, is at 4 milliamps on the Idp. As you have 4 milliamps on your signal generator, or if it's coming from the actual PLC from the system, At 4 milliamps, this gauge should have 3 psi on it. At 20 milliamps, this gauge should have 15 psi. Basically, what that's telling you is kind of a health of this IDP. That if you're putting 20 milliamps on this IDP and you're only getting 10 psi, there's several factors. I mean, it could be that this plate, somebody's loosened this plate could be loose, the diaphragm could have ruptured, this gauge could be damaged, this plug could be loose. So the I-port plug that he showed at the kind of early on. So the first thing I would check is make sure that gauge port's, if you don't see at 20 milliamps, if you don't see 15 psi on this gauge, first thing I would do is tighten this port, this plug. It's a 6 millimeter hex. Tighten it down, make sure it's tight. If you still can't get full pressure out of that, there's a good chance your IDP has got some water or moisture and had an issue. But generally speaking, IDPs generally don't have a weird output. They're kind of a no-go thing that they either work or they don't, for the most part, with the exception of sometimes they get moisture in them and the flapper will stick. So as soon as you put pressure on them, you'll actually see this gauge shoot the moon and it'll go full pressure because the regulator part's stuck. So you guys do have, so you are using the Soldo limit switch, correct? Or feedbacks?
Yes.
Okay. So you've got the kit. So I've already kind of pre-installed part of the kit. And is there anything on that, anything I've gone over that y'all want to talk about before I go to putting the feedback on it?
That all makes sense.
Is there any situation where we would have to calibrate or adjust the IDP?
No. Excellent question. And
yes.
I was going to talk about that. Do not touch the IDP, those screws on the IDP. They are very finicky and you'll get way off really quickly and then the IDP will become non-functioning. So
Randy, that's the way it sounds like we were instructed to calibrate it before. So that's the only thing we do.
Well, I guess he just tried it. And you can move the ball with that.
That's adjusting that 3 to 15 psi.
If we can't get those other 2 screws on the side of the box to work, we will then switch to, exactly.
Okay. Yeah.
You're more than welcome to.
We've seen it a bunch where people they've never seen the product, weren't familiar with it, didn't know this was the zero span for calibrating the positioner, and they tried to calibrate the positioner through this. Sometimes you could probably get close to making it happen, but it's not going to be right. It's not the proper way to do it. But what this really is, if you have adjusted these and gotten these way off, ignore what these gauges are saying and just read this gauge. At 4 milliamps here, you should see 3 here and 15 here. I mean, 20 here, you should see 15 here. That's the only thing that's doing. It doesn't change. We don't want to change the rotation or anything of the positioner through these calibration boards.
Right.
And like I said, worst comes, I mean, that's if you've got one that you think that somebody's already dealt with and has adjusted it and changed it, just double check it here. But otherwise, you should never touch that. You never should have to touch that. If there's a case where you put 20 milliamps on this and you don't see 15 psi on it, and it's a brand new out of the box positioner, like I said, first thing you want to do is start looking at the IDP plug. Maybe make sure the gauge is not leaking. But it shouldn't have to ever calibrate the IDP itself.
And well, we have the rest of the past. So that's how we were told to tune these previously.
Okay. Yeah. Yeah.
I'm glad we're having this talk.
Yeah.
Exponentially.
Somebody else showed us different, and it's way off.
The complete opposite, actually.
Yeah. Wow. That's not good.
And honestly, like I said earlier, when you get one of these in, if it's just going on a regular 90-degree actuator, like a rack and pinion or easy torque or Scotch yoke or whatever, it is going from 0 to 90 degrees of rotation. Right out of the box, if you have to turn either one of these screws more than like a turn, something's off, because every one of them's tested to 90 degrees and roughly calibrated at the factory to 90 degrees to prove operation and the functionality. They don't actually, they're not telling you that, hey, you can throw it on a position, actuator, and it's going to be good to go. they get you in the ballpark and make sure it functions properly. So like I said, if you get to where you're having to crank on either one of these screws in here and make multiple turns, then stop, step back a second, kind of look at the situation because something's not right.
Yeah,
all right, so if we're pretty happy with, got any more questions about the calibration? I mean, we can go back to it, but I'm gonna go ahead and I'm gonna mount up a soldo and we'll look at calibrating it, making sure our, go through calibrating that. So if you have a positioner and somebody throws it on and then they just put a position feedback on one of the soldos and they didn't take the time to calibrate the positioner, you're gonna be chasing your tail because calibrating the feedback without calibrating the positioner is pointless. So I've kind of, like I said, you guys have done these. What I had to do was I had to mount the little adapter to the top of the spindle. Went ahead and bolted the cover to the plate, bolted through. Now I've got the soldo is mounted. We're at the 4 millionth position, slots up and down. Make sure that the shaft is slotted up and down. And we're going to mount this guy up here. Make sure that it is lined up. Now you'll notice inside of the soldo, there's a couple things to look at. And I don't know if it's going to show well on the camera or not. But you can see there's a couple lines drawn. There's a red line that large gear and small gear should line up when you're at the 0 position. So we're fully closed. Those should be lined up. And once we go to 90 degrees, you'll notice there's a black line here and a black line here. Those will line up. So as long as you get this thing configured properly and set in there correctly, the other thing is inside here, there's a jumper for direct and reverse. We're going to be direct. So that means as we increase signal on the positioner, it's going to go towards the open. So as we increase signal, it's going to go towards the open position. As this goes towards the open position, its signal output's going to increase. Like I said, our little handy dandy Mr. Signal, I can read and generate at the same time. A lot of the devices you guys may see, like we talked about before, like an Amatec or a Druck or a Fluke, most of those, if you want to generate a signal and drive the positioner to a position and read the feedback, you need 2 of those. So you'll need one to drive and one to read. Luckily, this does, but we can do both with the Mr. Signal. So what I've got here, I don't know if you guys will be able to see very well, but I'm at 4 milliamps of input, and you'll see the bottom line here is showing me that I've got 3.936 milliamps of output. Means I've got a good start, and inside the soldo, you've got a 0 and a span potentiometer, which are going to be real hard to show on here.
The little blue boxes?
Yeah, the little blue boxes here, the 0 and the span, and they're both marked. That the top one is your span, the bottom is your 0. And what you're going to want to do is those are just kind of fine-tuned potentiometers. So what you're going to do is you're going to adjust. We're just going to adjust this until we see as close as we can get reasonably. I'm reading out to 3 decimal places, which is a bit excessive, but
yeah, you don't need to read out the 3.
No,
1 decimal place is good enough.
Yeah, two sometimes pretty tough because they're pretty sensitive. So we're at 4.009 at 4 milliamps. What I'm going to do is I'm going to drive to 20 milliamps, and you'll see as we increase signal, we're increasing output. So we've increased signal, we've increased output to 20.92. And what I'm going to do is I'm going to go to the span and I'm going to adjust it until we're close to 20 milliamps. So we're really close there. So 19.998. Want to go back to 4 milliamps and check out the 4 milliamps and see if we need to adjust it a little bit. We'll adjust it somewhat.
Merchant said they're going to reach out to y'all to get one of these for us, so that'll be huge.
So this still doesn't answer the fact why is it calibrated.
It's all because it's not calibrated. That's why, because we get it calibrated. And it goes out 2 weeks later.
Can vibration make these
We might think we have it fully calibrated.
go uncalibrated per se?
Okay, what now?
Can anything going on, like for instance, you know, we get vibration at the rigs, there's shitty air pressure coming in at the rigs. Can any of that make these uncalibrate, or is it once they're set, they're set? Because we've had some that we've sent out, and all of a sudden out of nowhere they go off the wall and stop working the way they were. Is that something
Now,
that's a possibility, or?
Is that on the positioner side or the feedback side? See, because if it's just indicating differently, but if you go out and it's like, well, let's just say that you've got it calibrated and it's running at 75%. Well, the valve stays at 75, but for now, for some reason, the feedback back to the PLC is showing 25 or whatever. Then it's something to look at. Maybe it has something has happened to the soldo, to the feedback part. But, you know, that, so a lot of times you can't just rely on what the computer screen shows you. Sometimes you actually have to, you know, they have to verify with their eyes to make sure something hasn't happened.
Well, we've had that happen, and we've also had where there was 2 rigs that didn't hook the air supply back up. Obviously, that was part of the issue. One plugged it back in, it went back to working. The other one, we plugged it back in, and it would only go from 0 to 80. Would never go full open on that, and we could never get it calibrated back at the rig. Is that something that you guys have ever seen before, or something that possibly something's getting loose internally, or maybe, I don't know, we're just trying to find whatever solution we can to.
With that being said, though, there's been times we've had it fully calibrated, and then we'd go home, and with it just sitting in the shop, we'd come back the next day, and all progress was erased.
You know why, though? No. Because we didn't have the thing to tell us exactly where we were at. So we might have had it off, and that air just bleeding the whole night, at a slow pace, because we never knew where it was at. Now that machine is going to tell you exactly where you're at, 4 and 4 or 20 and 20. This machine is going to tell you everything.
I get you what you're saying on that, but how would it bleed off pressure without it? Like
because sometimes it has a delay. So whenever we're setting it, we're not letting that whole delay stop. You know what I'm saying? So at the end of the thing, when we think we have it, that delay's going to kick in, and the air's going to bleed. You know what I'm saying?
Can y'all hear us or our conversation?
Yeah.
Are we making any sense?
As far as why it would change, you know, from one day to the other, I don't have a good answer for that. I don't know why it would, because I don't see that. If I can calibrate this positioner right here in this feedback here today, and I can cut off the air and I can cut off the power, and I can come back 5 days from now, and it's going to be the same. And we do that repeatedly. That there's positioners I have here that I use for test units that I don't have to now when I start to change components, obviously, then you need to look at recalibration. But yeah, so as far as it changing totally on the calibration overnight by just walking away from it, I don't have a good answer for what would cause that, because it's nothing here. Because the only thing that can change the calibration of that positioner is the adjustment on this 0 and the span screw. Now, I'm not going to say it's not possible that if you've got something that's a spring return actuator, let's say, and it's sized in a certain way that, you know, with your compressor running or compressor being on or off, so you may only have 80 pounds of air one time you may have 110 pounds of air. That's definitely going to change that, because that spring range, that spring set in that actuator is going to affect what pressure it takes to move to a certain position. But on a double acting, you shouldn't see any, I mean, even pressure change shouldn't really affect it, as long as it's enough pressure to operate it.
And just to hit home a point also, I mean, these positioners are in lots of different industries, but one of the ones that's really, really nasty and hard on components like positioners is the pulp and paper industry. And we have a lot of these in pulp mills where they see vibration constantly all the time. So vibration to me wouldn't be a cause unless it's something absolutely crazy where they're having issues with any sort of instrument on the rig.
What about humidity getting in there, moisture? Would that reset it?
Would not reset it. Moisture is going to have an effect of basically killing the electronics. That's why we'd recommend filter regulators nipple mounted to the positioner, or a good dryer system on the compressed air system.
Now, moisture in your compressor system, getting, like Randy said, into that pilot valve may cause, it's not going to change the calibration. It's just going to change the positioner's ability to get to the right set point. Because as that spool moves, like Randy talked about the lubricating property of the gold, I talked about the air bearing. If that spool starts to drag, so a real small set point increase you may not see any movement. Then it takes a much larger set point increase to finally overcome the friction in that spool. And then what happens a lot of times is you'll see it way overshoot. So, let's say we're running at 50%, but we need to change to 51%. If that spool's dirty, you're going to see 51%, nothing's going to happen. 52%, nothing's happened. You may have to get up to like 65% before you overcome the friction in that spool. Well, now what happens is it shoots past 65% because it's trying to move, and it has to chase its tail back to the 51% it's looking for, and it starts oscillating. What we call oscillation is it'll overshoot and come back. And so it looks like the calibration's screwed up, but really what it is a dirty pilot because it can't get to the set point it wants to go to.
Okay, what is your solution for keeping those dry? Because we've got an air-water separator for the line going in. Is there any other solutions that you guys have to keep moisture out of there?
We just recommend using coalescing filter regulators mounted directly as you can to the position. And that's no guarantee that we all know that plants get these, get dirty air, or any places you are could get a slug of water. These guys right here are meant to remove moisture from air. They can't make air out of water. So if you get a slug of water put into this basically becomes a lubricator, and it's starting to dump water into the position. So there's only so much they can handle. There's only so much you can do, but it's a good insurance that it helps. That somebody says, hey, we've got it, like I said, we got air water separators, we've got desiccant filters, but you look and it's 80 feet away, and that line runs past something hot, then back out into atmosphere where it's cooler. So you're going to see condensation inside that line beyond your dryers or filters. So the closer you can mount a coalescing filter regulator to these, the better chance you have of lengthening its life.
Okay. And then real quick, for instance, working them in our shop. Like I said, we have some that take 45 minutes. We have some that take 4 days. Mm-hmm. Being open and exposed out with, granted it's West Texas, we get rain like 3 times out of the year, but with that, or even the humidity from, for instance, our portacles, would that be enough to start damaging these or not? Because what I'm saying, if it's open and exposed for 4 or 5 days, would that be enough moisture in there? Or do you think possibly the condensation from somewhere else in the lines? Because we've got a big dryer going to our air compressor, a massive one. And we have a water air separator that this goes through as well. But we did find a little bit of moisture in 2 of these the other day that have just been sitting in our shop.
I would say a porticle is not really going to give you that much of an issue.
We shouldn't be that afraid of this water.
Right. Nothing that you're saying alarms me, except for you say it's open. Are you saying that you have it like Scott has, like it's open with the AP?
Because we're trying to sit here and tweak them, and if it worked and we got them done in 45 minutes, great. But when these ones are taking 4 or 5 days.
Yeah, as long as it's inside, there should be no issues at all. It can see some moisture. That's not a problem. What we're more concerned about is if there's a big slug of water coming through the airlines, or that you have it uncovered like you have it like it is now, and you put it outside and it does rain for some reason.
Oh no!
That would be extraordinarily bad.
Yeah, a porticle just misting on it. you don't want it to get wet, but that shouldn't hurt it. I don't see any real issues with that. Because, ours just sit around open, and we're in Alabama, and it rains a lot and it's humid all the time, so it's a little different.
And then obviously they're buttoned up, and then we put a cover over it, so we're just making sure no drilling mud. And nothing should come into it hypothetically, but like I said, if that's from there, it would just be water coming in from that.
And one other point I want to make too is if we have this hooked up and there is compressed air going through it, that compressed air acts as basically an invisible force field around the positioner. It makes it very hard for anything to get into it from the outside, like water, for example, because there is a positive pressure on that positioner because, as we talked about, there's a bleed through that spool.
Okay, and then what about as far as where you turn it to set the span on the outside? That clearly has no gasket around.
Yeah, but that
plastic cover goes over that. And what about the vent line? That shouldn't allow enough to go in, correct?
That's correct.
Yes.
They gotta make sure.
You got to make sure that plug is, or that the zero plug that Scott has open right there. Scott, can you put your hand on it? That's inserted all the way properly.
Yeah.
What is that to pop off?
Yeah,
There's been several times I was working on it and it builds so much pressure on the inside, it just pops off.
That this pops off?
Yeah, and it's a big boom. And
there's air coming inside of the box.
Right. Why and how do we stop that?
Because that should be bleeding off out of the out before it would ever.
Is it because that?
Any pressure should bleed here. There should be minimal pressure inside the housing. There's actually a couple of other blow-offs.
There is.
There's one underneath this where there's a plate where all the connections are that mounts to the housing. There's actually a blow-off in there. And if you flip the unit upside down, you'll see that there's a little. Randy, can you show that where that other blow-off is?
If that box get full of air, what could be the problem? There might be a screw loose to hook up that other part.
Yeah. Were you talking about? You're talking about the reliefs on the back here.
No, I'm talking about sometimes they get that little plastic thing on the side that you just showed us.
Rubber. Okay.
This guy.
Yeah, you see the bleed out underneath it, the out. Right where. Yes, can that be blocked off some way or somehow? It's obviously supposed to bleed out, but was there any way that gets clogged enough to make it so it builds too much pressure in there to pop off?
Yeah. So this is brass. So salt water is what we fear the most with this. So like for example, down here on the Gulf Coast, a lot of guys will take this out and put a stainless steel cone in it. This really doesn't serve any purpose other than it's a muffler to silence the positioner and also to keep bugs from crawling in when there is no compressed air on it. If for some reason this keeps popping off, I would take this out to make sure that it is ventilating properly. Again, in order for this to work, this muffler does not need to be in there.
Okay, but with that sitting up underneath the rig floor and we take that out, how bad will that damage that box if it gets full of contaminants?
Destroy it.
Well, part of what we're talking about, one good thing is that Idp does bleed a little bit into that housing. So it keeps a small positive pressure in your housing. So it helps to keep contaminants out. So the only time you really see contaminants get into one of the inside of the housing, the main positioner housing, is when a cover is left really loose and that little bit of positive pressure can't really do its job to help purge the whole housing. So getting enough pressure to blow this out, I suppose there's a couple things that could happen, but I've seen people actually take this out and put a plug in its place, and I've never seen it pop one of these out. I haven't seen it. I'm not saying it's not possible or it's something you're seeing. I don't know. I'd have to try to make that happen.
Yeah, it's something's plugged in the exhaust port if that happens.
That's what it sounds like.
Pretty serious bad.
Hey, Randy, was that on the bottom of that box? Were you pointing out is that another bleeder?
Yeah.
At the bottom?
Yes.
Some of
the only. Hang on. So yeah, so we have a couple like check valves here. So that's another, what will happen here is if moisture is inside the positioner, it'll push it out through these little bleeder valves too.
That's another one, Randy, right there.
Yeah, some of our rigs have to mount these valves somewhat, upside down, like pointed straight down. If not at an angle.
It doesn't matter how it's mounted.
Yeah, it should have positive pressure.
Yeah, I'm gonna have to see what I can do to make one. If I can make one of those blow out, and it may be that 80 psi or 60 psi can bleed off enough where it maybe at 110 psi it can do it. That once you that if the filter's plugged or the outlet's plugged.
I don't know. Somebody was asking, and I know, Scott, you already answered them, but what about drastic temperature change? Will this affect calibration? And no, it will not. It will not affect calibration. Drastic temperature change, the only thing I think about when I think about drastic temperature change is the airlines. If they're going from inside to outside, condensation builds up, and that's where that coalescing filter that we talked about comes into play.
Okay, yeah, we'll have to see if we can source some of those from you guys too. Well, I'll ask the guy when he gets here.
Yeah, I'll talk to Mike too. He just texted me. He said, I understand you're talking to these guys, so. Do you guys have any other questions? I think we kind of uncovered a few things.
Yeah, we uncovered main things.
Yeah, y'all have been a huge help. Definitely appreciate both of your time, for real.
Yeah.
No worries. I'm glad we could do this and help you all out.
Whole time we've been doing it way wrong and
Completely backwards.
Yeah.
getting us up in the right direction.
Yeah, we were just told wrong from the get-go, unfortunately, but that's huge knowing this now, because hopefully we could go back in there and get this one squared away and have a happy customer by the time we're done with it at the end of the day.
And feel free to call me anytime, even over the weekend, if you're having issues. I will say, if you call me, after 5 o'clock on Friday, I might have a few cold beverages in me by then. But I'm pretty versed in giving great answers at that point. So.
Or at least interesting answers.
Yeah. Appreciate it. Awesome. Thanks so much, guys.
Hey, no problem.
All right, well, I'll talk to you later, hopefully. Well, hopefully we don't have to call you later, but we'll see.
Anytime.
We're here if you need it.
Thanks again. We'll talk to you guys later.
Thanks, guys. Very informative meeting. Very good.
You're welcome.